These are pictures of the numbers 1 through 10. No matter how bright, no matter how dark, and no matter how weirdly oriented, our minds are able to seamlessly recognize them. But get a computer to do it, and all of a sudden it becomes an overly complex, daunting task. And that's where neural networks come in. Inspired by the brain, neural networks are able to make predictions by making mistakes and learning. From speech recognition to self-driving cars and even to diagnosing diseases, its applications are endless. But before we get too far ahead, it all starts with a simple perceptron. A singular neuron with an input layer, a hidden layer, and an output layer. Each connection is assigned a weight, which represents how important the input is to the neuron. The larger the weight, the greater the importance. And in the neuron is an activation function, with the input being the weighted sum from the connections plus a bias that offsets this value. And there's so many different types of activation functions, one being the rectified linear unit, which fires if the weighted sum is greater than 0. And with more neurons, a neural network is formed, and the neurons use patterns that they think are important for determining the output. But how do they find these patterns? This is where the learning part of machine learning comes into place. To better explain this concept, I learned to ride a ripstick. Over the course of an hour, I would make countless mistakes, from being imbalanced to not moving fast enough. From this, I would make changes and find patterns of what works, then slowly become better. Now, how does a neural network do it? Imagine you had a neural network that tries to differentiate between cats and dogs. The inputs would be the pixels of the image, and the two outputs would be the probabilities of it being a cat or dog. The neural network quantifies the mistakes it makes through the cost function, which is simply the average of all the predicted values minus the actual values squared. A graph of the cost function can be created with the x-axis being the weights. For simplicity, there are only two axes shown, but the dimensionality of the graph is based on the number of weights. The goal of learning is to minimize the cost function. Through a process called gradient descent, the slope is calculated to determine in which direction the weight should step to reduce the cost. The learning rate determines how large of a step it takes. Thus, the neural network iterates through the data, adjusting its weights, minimizing the costs, finding patterns in the images, reducing its errors, and learning. And with the help of neural networks, I developed a glove to translate ASL to text. The neural networks aid in identifying the facial expressions of the user. So now that we've reached the end,